In the mid-1960s, astronauts on the early Gemini missions were orbiting a largely unmapped Earth. Looking down at North Africa, they saw the Sahara Desert as an endless, featureless sea of sand and rock. As they passed over Mauritania, a sharp geometry broke the monotony. It was a perfectly concentric circle staring directly back at them. The shape was so distinct that crews began using it as a fixed navigational landmark to track their orbital paths. Up close, the scale of this formation is staggering. It spans 40 kilometers across, composed of several nested rings etched straight into the crust. A geometric shape this large and precise requires a massive release of energy to form. Geologists immediately set out to determine what kind of force could carve a bullseye straight into the Sahara. The most logical answer was an asteroid impact. When a space rock hits the Earth, it typically excavates a perfect circular bowl with raised edges, leaving a permanent scar on the landscape. To confirm this, geological teams trekked deep into the remote Mauritanian desert. They were looking for the standard debris left behind by high-velocity cosmic collisions. When they sampled the rock, the telltale signatures were completely missing. They found zero traces of the extraterrestrial metals typically vaporized in a strike, and absolutely none of the shocked quartz that forms under the immense pressure of an impact. Without those physical markers, an asteroid could not be the cause. The rings resulted from a terrestrial process, meaning whatever carved this shape came from Earth itself. If the energy didn't come from above, it likely came from below. A violent volcanic eruption or a collapsed caldera often leaves behind a massive circular depression. To prove a volcanic origin, geologists scoured the concentric ridges for deep Earth materials. They expected to find deposits of basalt or ash, the standard signature of magma breaching the surface. The rock analysis told a different story. The sedimentary layers had never been subjected to the intense, sudden heat of an eruption, and the material was entirely wrong for a volcano. With violent explosions ruled out from both space and the deep Earth, scientists realized the structure was carved by a much slower process. Winding the clock back roughly 100 million years, extreme tectonic strain was pulling the supercontinent of Pangaea apart, creating massive rifts across the globe. Deep beneath what is now Mauritania, a plume of liquid magma was pushing its way up toward the crust, but it never quite reached the surface to trigger an eruption. Instead, the magma stalled, creating an immense pocket of subterranean pressure. This forced the flat, sedimentary rock layers sitting above it to slowly bow upward into a colossal dome. Geologists call this hidden tectonic blister an anticline. It provided the 3D architectural foundation required to eventually reveal the giant eye. Once the dome was pushed up, it was subjected to deep time erosion. For millions of years, heavy rainfall, ancient river systems, and relentless Saharan winds scrubbed away at the newly elevated peak. Slicing the top off a 3D domed structure naturally reveals a 2D pattern of concentric circles in the cross-section. But the ground here wasn't uniform. The blister was composed of alternating layers, incredibly tough, heat-baked quartzite stacked directly against much softer sedimentary rock. As weather battered the flat surface, the soft sedimentary rock was quickly scoured away to form deep circular valleys. Meanwhile, the durable quartzite resisted the elements, remaining elevated to form the sharp, raised ridges we see today. Because the uppermost layers of the dome were completely stripped away, the rock sitting at the exact center of the bullseye is actually the oldest material in the entire formation. Millions of years of selective erosion and subterranean pressure transformed a hidden dome into this intricate, concentric landmark. Today, walking through the Richat Structure means navigating dry, winding valleys and harsh canyons that seem entirely static under the baking sun. While the geometry suggests a sudden cosmic accident, the actual mechanics are far slower, driven by the steady rhythm of deep time. It took the immense lifting power of a hidden magma chamber, paired with the relentless scrubbing of atmospheric erosion, to draft Earth's largest bullseye. Scientists can now hike through these rings and walk back through time, navigating an exposed cross-section of the planet's crustal history. The structure reveals the Sahara as an ancient, dynamic recorder of the invisible geological forces that